back to another video. In this episode, we are going to look at how we can find the mode of a particular distribution. Precisely, the distribution is in the CDF form, so we want to find the mode. How do we do this? So here we have this function in this piecewise function is in the CDF form, and we want to find the mode. So what do? We have to change the function into the PDF form before we can find the mode. Okay, so how do we do that? Our usual way, you differentiate the function given, you differentiate the CDF to get your PDF. So you see the function we have here, when you differentiate 0, it's a constant, so you don't forget about that. Then you differentiate the function that you have been given. So you know that the differential of the CDF will give you the PDF. Okay, so this is what we have. So f of x will be equal to the differential of the CDF. And the CDF here is 109 into 2s squared minus s cubed over 3, right? So this is what we have, okay? And we want to differentiate it to have the PDF. So our f of x will be equal to 109 differential of the CDF, which is 2s squared minus s cubed over 3, right? So this is 109 into 2s squared minus s cubed over 3. So I factored out the 109 because it's a constant. Okay, so when you differentiate this, when you differentiate 2s squared, you're going to have 4s over here. And then when you differentiate s cubed over 3, you're going to have minus 3s squared over 3, right? So basically, f of x will be equal to 109 into 4s minus this 3 on 3 will go, so we have s squared, right? So now we have our PDF. So this is our PDF, 4x minus s squared over 9. Okay, so once we have our PDF, we are interested now. This PDF function, we are coming to differentiate it to find the mode. When you need the mode and you have the function or the distribution in the PDF form, you differentiate it, then set it to 0 to find the critical values. That is the values of x. Okay, so now we have changed it from CDF to PDF. So now let's differentiate the PDF and set it to take it to 0. Okay, so when we differentiate the PDF, right? When you differentiate the PDF, we are going to have first differential of the PDF will be equal to 109 into 4 minus 2s over here. So we have the first differential of the PDF. Okay, so this result, you send the first differential to 0 to find the critical values, and that result becomes the mode of the distribution. So we set this particular one to 0. Okay, so when we do that, that means we are going to have 109 into 4 minus 2x equals 0. Okay, so we come here and we have 109 into 4 minus 2x equals 0. So basically we have 4 minus 2x equals 0. Then we can say that 2x equals 4. So x is basically equal to 2. So if you want to confirm if indeed this is the mode or the value of the mode of the distribution, then you take the second derivative of the PDF. Then you can see the confirmation. So try, if you take the second derivative of this, you are going to have f prime of x will be equal to 109 into negative 2, right? So this is giving us a negative value. That should tell you that the the function or the mode is, since this is negative, since the second derivative is negative, we can say that f of s has a local maximum. So this becomes the mode of the distribution. So the second derivative has a local maximum, which is -2. So that confirms that x equals 2 becomes the mode of the distribution. So therefore, or thus, the mode of the distribution is 2. Okay, so this is basically how we find the mode of a particular distribution when we are given the CDF. First, you change the CDF to a PDF form. Then when you have the result, what you have to do next is that the result you're having is in the PDF form. So take the first derivative of that result, set it to 0, and then find the critical values, that is the values of x, and those values becomes the mode of the distribution. And if you want to confirm if that result is indeed the values of the mode for the distribution, you take the second derivative of the function that you have. Okay, so when you take the second derivative, if the sign is negative, then it means that it has a local maximum, and if the sign is positive, then it means that it has a local minimum. So this confirms that the mode for this particular distribution is x equals 2. The mode of the distribution is at x equals 2. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.